Click the bell icon to get latest videos from Ekeeda.
Hi friends, so today we are going to learn about eigenvalues and eigenvectors. But before that, let us talk about what is linear dependence and independence of vectors with theory and also followed by few examples related to it. So let us understand linear dependence and independence of the vector. As the name suggests, you will be given few vectors and those vectors are linearly independent or dependent on each other. That is, if they are related to each other, that is, can we express one of the vector as the form of addition and subtraction of another vectors as taken combination of rest of the vectors. So let us check out. If we have got, let us start with the definition. If we have got x1, x2, x3 such as xn, n vectors we have got, and we have got few constants k1, k2, k3 up to kn which are not equal to 0. This is very important. So these vectors are not null vectors, they are not void vectors. K1 has got some value other than 0, K2 has got some value other than 0. So K1, K2, K3, Kn, these are constants and which are not equal to 0. So if we have got K1 into x1, this is the scalar multiplication we have taken corresponding K1 and x1. Then K2 into x2, K3 into x3, such up to kn into xn, and all additions we have taken. And if this comes out to be 0, this is not 0, this is O, and this is denoted for null vector. And if this comes out to be null vector, that is all the values of this vector is equal to 0, then we can say x1 up to xn, these vectors are linearly dependent. And if k1, k2, k3, these all are 0, that is, there is no correlation between x1, x2, x3 amongst them up to xn, and the only way to express this addition to be 0 is to have k1, k2, k3 up to kn is equal to 0. If we have such condition, then we can say x1 up to xn, these vectors are linearly independent. Why linearly independent? Because there is no correlation between them. So let us start this with actual example and let us understand where we can apply this. So let us start and understand what is linear dependency and independency of vectors by taking actual examples. So let's start. Examine whether the vectors x1 311, x2 20 minus 1 and x3 421 are linearly dependent or independent. So we are supposed to check this 3 by 3 vector, or we can say order 3 vectors x1, x2, x3, as there are only 3 elements, so we'll say the order of these vectors is equal to 3. So let us start with the first equation, standard equation which we had considered. K1 x1 plus K2 x2 plus K3 x3 is equal to O. This is not 0, this is O, that is null vector. Okay, so let us put all these values x1, x2 and x3 and find out what are the values of k1, k2, k3. If the values of k1, k2, k3 comes out to be 0, then we say the vectors are linearly independent. And if k1, k2, k3 has got some values that is not equal to 0, then we'll say the given vectors are linearly dependent, and will show what is the linearly dependency, that is how one vector is related to another vector and how we can show one particular vector as the combination of another 2 or 3 remaining vectors. So let us start with this. Therefore, k1 into, we'll write down 3, 1, 1 plus k2 into 2, 0, minus 1 plus k3 into 4, 2, 1 is equal to 0, 0, 0. Now these values are 0 and the total, this row vector is denoted by O. So therefore, now we'll actually multiply and write down the equation. Therefore, we'll consider first element, that is 3k1, 2k2, 4k3 is equal to 0. First element multiplication, first element is equal to first element. Likely we'll solve for second element and as well as for third element. So therefore, 3k1 plus 2k2 plus 4k3 is equal to 0. Now second element, 1k1 plus 0k2 plus 2k3 is equal to 0. And now third element, 1k1 plus minus 1k2 plus 1k3 is equal to 0. So we have got three equations, 3k1 plus 2k2 plus 4k3 is equal to 0, k1 plus 0k2 plus 2k3 is equal to 0, k1 minus k2 plus k3 is equal to 0. Now in order to solve this, we'll convert this into matrix form. So we'll have all the coefficients in one of the matrix, then we'll be having all the coefficients which are k1, k2, k3, and on the right hand side we'll be having all these coefficients of particular equation, that is 0, 0 and 0. So let us start with this 3, 2, 4. These are the coefficients. So let us write down 3, 2, 4. Then we have got 1, 0, 2, 1, 0, 2, then 1, minus 1 and 1. And we have got k1, k2, k3, and we have got 0, 0, 0. We'll write down 0, 0, 0. As you can say, when we multiply one matrix with another, we take first row and multiply with the column. So 3k1, 2k2 plus 4k3 is equal to 0. This is what the first equation is all about. Now let us focus on second row, which is 0k1, 1k1, 0k2 and 2k3 is equal to 0. And third one, k1 minus k2 plus k3 is equal to 0. So now my job is to have first element over here is equal to 1. So we have got 1 over here, 1 over here. So what we can do, we can transfer first row and third row. That is interchanging first row and third row. The operation is called R13. Let us perform this operation called R13. So first column will get transferred to third and third will be here. So basically k1, k2, k3, these values we don't have to change. We'll just interchange first and third one, which is 0 will be going here and this 0 will be going here, which is nothing but the same. So therefore we'll be having 1, minus 1 and 1. Second row 1, 0, 2 will be as it is, and 3, 2, 4 will be as it is, and we have got k1, k2 and k3 is equal to 0, 0 and 0. So after having this particular first element as 1, we can have all the elements underneath this 1 and 3, all the elements below this 1, that is 1 and 3, to be 0. So in order to make this 0, will freeze this r1, that is r1, row 1 is constant, and will perform something on r2 as well as r3 in order to get these elements is equal to 0. Now we can see 1 minus 1 is equal to 0, so we can have r2 minus r1 and 3 minus 3 into 1. So we'll be having R3 minus 3 into R1. We get. So first row is going to be the same. 1 minus 1, 1. Once we perform R2 minus R1, 1 minus 1 is going to be 0. 0 minus minus 1 is going to be plus 1, 2 minus 1 is going to be plus 1. Now R3 minus 3R1, that is 3 minus 3 into 1 is going to be 0. 2 minus 3 into 1, which is minus 3, and 2 minus minus 3 is going to be plus 5, and 4 minus 3 into 1, which is going to be 4 minus 3 is equal to 1. And this is nothing but k1, k2, k3, and as all the elements are 0, and even if we perform anything, r2 minus r1, the value is going to be remain same, which is 0. r3 minus 3r1, that is 0 in minus 3 into 0, which is going to be 0. So these values won't be changed as we have got 0 over here. So now let us focus on the next one. So as we have freezed R1, that is row 1, now let us focus on R2. Let us freeze this one. So we have got 0 and 0. The basic element here should be 0, and we have got 1 over here, and such as we have got 1 over here, we should have 1 over here. So we have got 1 element over here. Now this will freeze this one, we'll keep it constant, and the element below this one, that is 5, and this has to be 0. So we need to perform R3 minus 5 R2, as 5 minus 5 into 1 is going to be 0. Therefore we get 1 minus 1, 1, 0, 1, 1. R3 minus 5 R2, 0 minus 5 into 0, which is again 0. 5 into 5 minus 5 into 1, which is going to be 0. 1 minus 5 into 1, which is going to be minus 4. And K1, K2 and K3. And we have got 0, 0, 0. Now let's convert this into equations. We have got first row into column is equal to first element, which is k1 minus k2 plus k3 is equal to 0. There is the first equation. Now second row into column is second element, which is 0 into k1 plus k2 plus k3. So k2 plus k3 is equal to 0. And the last but not the least, 0 into k1, 0 into k2 and minus 4 into k3 is equal to 0. From here clearly we can get k3 is equal to 0. Now we'll put this value over here and we can have k3 is equal to 0. So k2 plus 0 is equal to 0. Therefore we can have k2 is equal to 0. Now we can have this values over here. Therefore we can have k1 minus k2 plus k3 is equal to 0. This is k2 is 0, k3 is 0. Therefore k1 minus 0 plus 0 is equal to 0. Therefore k1 is also equal to 0. So we have got k1 is equal to 0. k2 is equal to 0 and k3 is equal to 0. Therefore, k1 is equal to k2 is equal to k3 is equal to 0. In the beginning only we had decided k1 into x1 plus k2 into x2 plus k2 into x3 is equal to 0 if the values of k1, k2, k3 are non-zero, that is k1, k2, k3 are not equal to 0, then we say the given vectors are linearly dependent on each other. But here we have got k1 is equal to k2 is equal to k3 is equal to 0. That is, we cannot have or we cannot find any relation between x1, x2 and x3. Therefore, these vectors are called linearly independent of each other. Therefore, x1, x2 and x3 are linearly independent. So, hence proved. So let us take another example which are linearly dependent. The last example we saw was linearly independent. So let us focus on the same. The procedure is going to remain the same. It is just the values of k1, k2, k3. They decide whether the given vectors are linearly dependent or independent. So let us focus on the same. We have got three vectors of order 4, x1 as 1 2 3 4 4 elements, x2 as 3 minus 5 2 6 4 elements, x3 as 2 minus 1 3 4 are linearly dependent. So we are supposed to find, are these vectors x1, x2, x3 are linearly dependent? If so, then express x1 as a linear combination of vectors. That means if these x1, x2, xa, these vectors are linearly dependent on each other, then we are supposed to express x1 as the form of addition and multiplication of x2 and x3. So let us find out. So procedure is going to remain the same. The equation k1 x1 k2 x2, this equation we are supposed to consider k3 x3 is equal to O. Therefore, k1 into x1 is what? 1 3 4 2 plus k2 is 3 minus 5 2 6 plus k3 is 2 minus 1 3 4. It's going to be O. Therefore, first element will take k1 into 1, which is k1, plus 3 into k2 plus 2 into k3 is equal to 0. Then we'll consider second now. 3 into k1 minus 5 into k2 plus minus 1 into k3 is equal to 0. Then we'll consider third one. 4 into k1 plus 2 into k2 plus 3 into k3 is equal to 0. And last but not the least, 2 into k1, 6 into k2 and 4 into k3 is equal to 0. So 2 into k1 plus 6 into k2 plus 4 into k3 is going to be 0. Now let us convert this into matrix form. So all the coefficients will be written here. The variables k1, k2, k3, k4 will be written here and will be having 0 0 0 0, which is on the right hand side. So we'll have 1 3 2. Let us start 1 3 2. We have got 3 minus 5 minus 1, 3 minus 5 minus 1. Then we have got 4 2 3. We have got 2 6 4, 6 4. As we know, we should have this particular first element to be 1, and which we have got already. So all the elements below 1 should be 0. That means I need to make this 3 as 0, I need to make this 4 as 0, I need to make this 2 as 0. So in order to make this 0, the operations which we are going to perform is, first is to freeze this row. This row is not going to get changed throughout this problem. So in order to change this 3, we are going to perform 3 minus 3 into 1, which is R2 minus 3R1. Here 4 minus 4 into 1, which is going to be 0. So R3 minus 4R1. And last but not the least, 2 minus 2 into 1, which is R4 minus 2R1 is going to 0. So let us solve. So we have got R2 minus 3R1, R3 minus 4R1, and R4 minus 2R1 we get. So let us focus here. 1, 3, 2 is going to be same. This is going to be 0. Now minus 5. Let us perform this. Now 3 minus 3 into 1, then minus 5 minus 3 into 3, and minus 1 minus 3 into 2, which is we are going to write down. So minus 5 minus 3 into 3, which is minus 9, and minus 5 minus 9 is going to be minus 14. And minus 1 minus 3 into 2, which is going to be minus 7, which we are going to write. Now R3 minus 4 into R1. So 2 minus 4 into 3, which is going to be 2 minus 12, which is going to be minus 10, and 3 minus 4 into 2, which is going to be 3 minus 8, which is going to be minus 5. Here we have got 2 minus 2 into 1, 6 minus 2 into 3, and 4 minus 2 into 2, which is 4. So 6 minus 3 into 2 is equal to 0, and 4 minus 2 into 2, which is 4 minus 4, is again going to be 0. So we have got 0, 0, 0 over here, and we have got K1, K2, K3 is equal to 0, 0, and 0. Now we'll leave this row. I can see minus 7 I can take common, and also minus 5 I can take common. So performing minus 1 by 7 into R2 and minus 1 by 5 into R3, we get 1, 3, 2, 0, 2, 1, because minus 7 we have taken common, so this is going to be 2, this is going to be 1, and minus 1 by 5 into this, that means minus 5 we have taken common, so this is going to be 2 and 1, and this is 0, 0, 0, and K1, K2, K3, the values are 0, 0, 0, and 0. Now let us focus on these two equations. Now what are the equations we can get? We can have second row and third row as same. So I can perform R2 minus R3 in order to eliminate R3, and we get 1, 3, 2 as it is, 0, 2, 1 as it is, and as we are subtracting R3 from R2, so this is going to be 0, 0, 0, and 0, 0, 0. For K1, K2, K3 is going to be 0, 0, 0, and 0. Now we'll multiply this with this and with equate to first element. Now we'll take second row into K1, K2, K3 and is equal to second element. Therefore, so we have got 1 into K1, 3 into K2 plus 2 into K3. So K1 plus 3 into K2 plus 2 into k3 is equal to 0, and we have got 0 into k1, 2 into k2 plus 1 into k3 is equal to 0. Now we have got 1, 2, 3 unknowns and we have got only 2 equations. So in order to have solutions for 1, 2, 3 unknowns, and we have got 2 equations, so 3 minus 2, 1. Now one unknown has to be put any parameter t. Parameter t. If we have got m number of unknowns and n equations, so m minus n parameters we are supposed to put. So here we have got 3 unknowns and 2 equations, so 3 minus 2 is equal to 1. So one parameter t I am supposed to put. So let's consider k3 is equal to t. Therefore 2 into k2 plus t is equal to 0. Therefore 2 into k2 plus t is equal to 0. Therefore 2k2 is equal to minus t. Therefore k2 is equal to minus t by 2. Therefore I am putting all these values, k2 is equal to minus t by 2 and k3 is equal to t, in equation 1, which is k1 plus 3k2 plus 2k3 is equal to 0. Therefore we have got k1 plus, now the value of k2 is equal to minus t by 2 plus value of k3 is equal to t is equal to 0. Therefore k1 minus 3t by 2 plus t is equal to 0. Therefore k1 is equal to, now this minus 3t by 2 will be on the right hand side, it will become 3t by 2 and plus t will become minus t, which is going to be t by 2. Therefore the value of k1 is equal to t by 2. Therefore we have got k1 is equal to t by 2, k2 is equal to minus t by 2 and k3 is equal to t. Therefore I can have k1 x1 plus k2 x2 plus k3 x3 is equal to O. Therefore we'll put the value of k1, which is t by 2 into x1 plus minus t by 2 into x2 plus t into x3 is equal to 0. So all t will take common and will divide it by t. So I'll be having 1 by 2 into x1 plus minus 1 by 2 into x2 plus x3 is equal to 0. Now I'll multiply this with 2. I'm gonna get x1, 2 into 1 by 2 is 1, so x1, 2 into minus 1 by 2, which is minus x2, and 2 into 1 is going to be 2 into x3. So plus 2 into x3 is equal to O. So this is the dependency equation which we have found out after solving this particular example. So my question is x1, x2 and x3. Now the value of x1 the value of k1 you can say that is 1, k2 is minus 1 and k3 is equal to 2. So therefore k1 is not equal to 0, k2 not equal to 0 and k3 is not equal to 0, and therefore we can say these given vectors are linearly dependent on each other. So let us find out. Therefore x1 minus x2 plus 2x3 is equal to O. Now I am supposed to express this x1 as the linear dependent form of each other, x2 and x3. So this is equal to, this x2 can be taken on the right hand side, so this is x2 minus this 2 x3, and now we have expressed x1 is in form of x2 and x3. Thanks for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.